Hello and welcome to the video on rhombi and squares. By the end of this video, you should be able to identify a rhombus and a square and say what the properties of a rhombus and a square are. Let's start with a rhombus. A rhombus is a parallelogram with four congruent sides, so all four of these segments, AB, BC, CD, and AD, are all congruent to each other. Since opposite sides are congruent to each other here, a rhombus is a parallelogram. Now the idea that it's a parallelogram is extremely important because that immediately gives us lots of other properties for a rhombus. So because it's a parallelogram, its opposite sides are parallel to each other. It has opposite angles that are congruent. It has diagonals that bisect each other. And all those other properties that we're dealing with a parallelogram. So like I had said here, that makes the properties of a parallelogram true for each rhombus. Well, there are a few other properties which are unique to a rhombus itself. If a parallelogram is a rhombus, then its diagonals are perpendicular. So that is a property that is unique to a rhombus. So that's not true for all parallelograms, and that's not true for rectangles, just ones that are a rhombus. What this is saying is that if I drew my diagonals in, that the segment AC and the segment BD would be perpendicular. It means they make a right angle, which really means all four of these smaller triangles here are going to be right triangles. So again, if ABCD is a rhombus, then AC and BD would have to be perpendicular to each other. Another property which is unique to a rhombus is if a parallelogram is a rhombus, then each diagonal is going to bisect a pair of opposite angles. What this is saying is if I again put both diagonals in, if I draw in BD and AC, that the angle DAB is going to get cut into two equal parts. So angle BAC and angle DAC are going to be equal to each other. Now I just drew that in for one of the angles, but really that happens on all four. So angles BCA and angles DCA are also congruent. And because opposite angles are congruent, all four of those little angles really are. And it happens the same way with the other set of angles as well. So angle ADB and angle BDC are also congruent, as are angles ABD and BDC. Let's move on to squares. If a parallelogram is a square, then I know it has four right angles and four congruent sides. Well, since opposite sides of the square are congruent to each other, that makes a square a parallelogram. And since all four angles of a square are congruent to each other, so these are all right angles, that makes a square a rectangle. And since all four sides of a square were congruent to each other, again, not only were opposite sides congruent, but really all four are here, that makes a square a rhombus. So really all the properties of a parallelogram, all the properties of a rectangle, and all the properties of rhombus are true for squares. Which means not only are all four sides and angles congruent to each other, but opposite sides are parallel, diagonals bisect each other, diagonals are congruent to each other, because that was a property of a rectangle. So DF is congruent to GE. The diagonals are going to be perpendicular to each other, because that was a property of a rhombus. And really any of those properties we've talked about so far. Let's try to visualize this again with a Venn diagram. We've done this before. So if I have this whole set of things called polygons, inside that set of polygons is a bunch of things. There's a set of things called triangles, there's a set of things called hexagons, and a bunch of other things. Well, the one we're going to focus on here is quadrilaterals. Inside that set of quadrilaterals, there was a subset called parallelograms. And inside the set of parallelograms, we knew that there was something called a rectangle, because all rectangles are parallelograms. Well, we now have two more shapes to add to this. Our two new ones for us here today is going to be the set of rhombus and squares. And really, rhombus, every type of rhombus is a parallelogram, so it's going to be inside the parallelograms as well. But there's also some rhombi which are rectangles. So it's actually going to overlap a little bit with the rectangles here. And this is the set of things that are rhombi, or a rhombus. Now, what's this overlap called? Well, the set of things where the rhombi and rectangles overlap each other, that's the objects that are squares. Because if something is both a rhombus and a rectangle at the same time, then it is a square. Let's try a few sample problems here. Problem number 1. If the measure of angle ABC is 50 degrees, find the measure of angle DAB, the measure of angle EBC, and the measure of angle AED. Well, first of all, angle DAB. Angle DAB is this angle over here, and since this thing is a rhombus, I know all the properties of a parallelogram are true for it. So consecutive angles are going to have to add up to 180. If angle ABC is 50, then 180 minus 50 is 130. Angle DAB is 130 degrees. Measure of angle EBC is really part of this 50-degree angle. Well, one of the properties of a rhombus is that the diagonals bisect those angles. So if the whole thing was 50, take that and divide it by 2, that angle is 25 degrees. And angle AED is the angle right here in the middle. Well, remember, one of the properties of a rhombus was that the diagonals are perpendicular to each other, so that has to be 90 degrees. Problem number 2. If AD is 13 and AC is 10, find EB. Well, EB is this length right here. Well, in order to do this problem, I'm actually going to use the Pythagorean theorem. Why can I do that? Well, the reason why I can do that is because the diagonals are perpendicular to each other. So this small triangle here is a right triangle. I know that AE here is 5 because a rhombus was a parallelogram, so the diagonals bisect each other. The length of AC was 10, so half of that is 5. So if I redraw that right triangle there, I have a right triangle with a leg of 5 and a hypotenuse of 13. I want to figure out what the other leg is. Well, I can do 5 squared plus b squared is equal to 13 squared, or Pythagorean theorem, because the 13 was my hypotenuse. And then when I evaluate that, I can solve for b. I subtract the 25 from both sides to get b squared is 144, and then when I square root, I get b is a positive or a negative 12. Well, in this case, we're talking about length, so I only want the positive one. Now I know that the third side here is 12. So on my picture, that's length DE being 12. Well, if DE is 12, I know that EB is also 12. Because again, the diagonals bisect each other. Those two segments are congruent to each other. So if DEFG is a square, we want to find the measure of angle DHG, the measure of angle HDE, and the measure of angle EFG. Well, the measure of angle DHG is just 90 degrees because a square is a rhombus and diagonals are perpendicular to each other on a rhombus. The measure of angle HDE is 45 degrees. Well, how did I know that? Well, the reason why I know that is because this is a right triangle again, because the diagonals are perpendicular, and the diagonals bisect each other, and the diagonals on a square are congruent because it's a rectangle as well, which means these two pieces here are the same size. Well, that makes triangle DEH a right triangle and an isosceles triangle. So if those two sides are congruent, both these angles here would need to be 45. And what's the measure of angle EFG? Well, EFG is just a right angle because a square has 4 right angles. That's 90 degrees as well. So problem number 4, if DH is 8, find EF. Well, if DH is 8, that's part of my diagonal. I know the other part here as well. And since diagonals are congruent on a square, because a square is a rectangle, these pieces here are also 8. So on this right triangle here, because diagonals are perpendicular on a rhombus and a square is a rhombus, I have another right triangle. I can do Pythagorean theorem. 8 squared plus 8 squared, because those are my two legs, is equal to EF squared. And using Pythagorean theorem, I get 64 plus 64 is equal to x squared. So 128 is x squared, and when I square root, I get the square root of 128. Well, that I can simplify a little bit. When I split that up, I could say that's a square root of 64 and 2. And when I take the square root of 64, that's 8 square roots of 2. And one last problem. Graph each quadrilateral with the given vertices, then determine whether it is a parallelogram, a rectangle, a rhombus, or a square. Let's start by graphing our points. Point A is at -2, -1. Point B is at -1, 3. Point C is at 3, 2. And point D is at 2, -2. Well, we want to figure out if this thing is a parallelogram, a rectangle, a rhombus, and or a square. Well, let's start with a parallelogram. Again, there's lots of ways to do that. My preferred method is slope, so that's what I'm going to do here. The slope of AB would be 3 minus a -1 over a -1 minus a -2. I get 4 over 1. I'll then do the slope of CD and get a -2 minus 2 over 2 minus 3, which is a -4 over -1 or 4 over 1. So I know I have one set of parallel sides. Now to do the other set of sides, we're going to find the slope of BC. Next, the slope of BC is 2 minus 3 over 3 minus a -1. That's a -1 over 4. And the slope of AD is a -2 minus a -1 over 2 minus a -2. I get a -1 over 4 again. So those are also parallel to each other. So with two sets of opposite sides that are parallel, I know I have a parallelogram. Well, that might not be it. Without really doing any extra work, I can tell right away that this thing is also a rectangle. And if I look at the two sets of parallel sides I have here, 4 over 1 and a -1 over 4, when I multiply those together, so that's a -4 over 4 or a -1. Since the opposite side had the product of a -1, I know that they are perpendicular, which means it has 4 right angles. That makes this thing a rectangle as well. Next, to figure out if it is a rhombus, I'm going to do the slope of the diagonals. If I do the slope of AD and the slope of AC, because if something is a parallelogram, then it is a rhombus as well if those diagonals are perpendicular. So let's do the slope of BD. A -2 minus 3 is a -5 over 2 plus 1 is 3. And then do the slope of AC as well. I get 2 minus a -1 over 3 minus a -2. And I get 3/5. Well, the product of those two things, a -5 over 3 and a -3 over 5, when I multiply those, I also get a -1. So I know these are perpendicular, which makes this a rhombus. And if something is both a rhombus and a rectangle and at the same time, it is also a square. So this object was all 4 of these things. That brings us to the end of our video on rhombi and squares. I hope you have a wonderful day.